Today, we will present the topic as a query search and query and understanding and voice search. I and my colleagues really coming from StubHub. So before this presentation, we'll introduce ourselves. So my name is Zhang. So right now, I'm working as an engineer manager of the catalog search and recommendation team in the StubHub.
And I'm William Yu, so I work as a software engineer with the search team under StubHub.
Yeah, before going into the detail of this topic, I'll have give you the background of the StubHub and our search platform. So I just want to know how many of you heard about the StubHub? Whoa, so many. I really don't know. How many of you really bought the tickets from StubHub? Okay, then later if you have any question, of course you can ask us. Actually, StubHub is the largest ticket marketplace in the world. So our mission is really to have the fans to buy and sell their tickets in our marketplace so that they can enjoy the live event. So StubHub founded in 2000. So then StubHub in 2007, StubHub become an eBay subsidiary. So after acquired by the eBay, so StubHub start to build a lot of partnership. For example, right now we have all the MLB team is our partnership. So at the same time, we also build a lot of partnership with other Premier League in the worldwide. So and also from the 2011, StubHub started the international journey. So until now, we are present in 48 countries. So just let you know, in early this month, we launched the Canadian site. So actually, besides this conference, if you're really interested in any local live events, you can go to StubHub to try to query them. Maybe you can buy some tickets to enjoy those events in the weekend. After that, I'll give a little bit of our search platform. Actually, our search platform is empower all the major search functions in the StubHub. So it's cover all the user experience from the ticket discovery, the event discovery, ticket researching, and also buy or sell tickets, or even view my tickets, all powered by the search platform. So right now, our search infrastructure is built on the SolrCloud. So with the foundation of SolrCloud, actually we have a lot of advantages. For example, right now the Zookeeper have the centralized configuration management. We can also easy to manage the data consistency between the different nodes. So at the same time, our full index and the incremental index become faster because right now we use the connection aliasing. So I think at the same time, we also build the centralized microservice layer so that whatever the request from client, they can also call through our API to get those search results from us. So I think with this foundation right now, StubHub is our search function can actually meet most non-functional requirements. For example, availability, scalability, performance. So right now, I think our search team is mainly focused on how to improve the relevancy. So today's topic is really one of the use cases we are working on, try to make a better user experience to our customer. So let's go into the details. So I would like William to give you the details.
Okay, can everyone hear me? Okay, so about a year ago, we were looking at example queries. So the ones on top, obviously very simple, just Giants or the, which is actually a name of a band, which is very confusing. And then the White Elephants is an alias for the Oakland A's. But the two queries on the bottom, concerts this weekend and find events in San Francisco under $50, we were never able to support initially. And we wanted to move from these simple queries up top to these kind of queries, conversational type queries on the bottom. But the issue was, as we went forward, each of these queries represented a certain challenge. So for the Giants, you have entity disambiguation. So we have, say, the New York Giants and the San Francisco Giants. If someone searches just Giants, it's difficult to tell initially who they mean. So this is kind of where the query understanding comes in. In addition to that, we also have the San Jose Giants to make everything a lot more fun. So again, on the, it refers to an artist. Obviously, if you just search the, and you just use that as a search query, it's likely that a lot of things are going to come up. And again, the white elephants, this is an issue for alias detection. And then concerts this weekend and find events in San Francisco under $50. We saw these as named entity recognition problems or entity detection. So like obviously concerts or events that would fall under a category. And this weekend or anything along those lines, or say like next October or something, these would be tagged as dates. And then San Francisco, a city, and then under $50, a price that we would work with and like translate into a Solr field. So we had an issue, and sorry, that issue was that we wanted to support these queries, but no one was searching this way yet. Everyone was kind of searching for the giants, the, and so on, mostly because StubHub search had for a long time supported only these queries. So then we were only going to get kind of shorter, simpler queries, and then we wanted to move forward and provide a better user experience, but also not compromise anything that we had. So for instance, if someone searches giants, you wouldn't want to end up on a musical performer at all. And we weren't confident working solely with some sort of machine learning based algo in order to make that happen. So we would only want to present performers and events that we were pretty confident about to begin with. So the first approach, very rudimentary. The issue was after tokenizing, the first approach that we tried was the bag of words approach, very rudimentary, but obviously we ran into some immediate concerns. The happy case here would be, say, a query like Taylor Swift concerts, you just tokenize those things and you remove the stop word, such as concerts. But then you have issues like Giants game, which is another happy case, but then you have an artist called The Game, where removing game it would be an issue, and also you would also remove the. And then going back to the band, to kind of use the example again, if you exclude the, you basically remove all the relevant information. And then if you try querying with the entire string, then a lot of results are going to come back. So again, we were trying to make sense of a query that users are putting in, such as find Giants tickets this weekend at AT&T Park. So we want to be able to map Giants to a specific performer ID. This weekend refers to a date range, and then AT&T Park is a specific venue that we have and can thus filter by. So moving down this path, we struck with another issue, and that was of ambiguity. So we have queries such as Bruno Mars weekend, which could refer to either Bruno Mars this weekend, meaning like a date range, or it could it be that Bruno Mars and the weekend are performing in the same event. And most people wouldn't type out the weekend the way it's properly spelled, but rather they would just, type it in quickly and conversationally. And we figured that the solution for this would be to get more user queries, except we still didn't have support for those user queries. So if we wanted users to type in more NLP style queries, or queries where NLP would be more useful, we would need to at least provide some initial support for that behavior. So just to reiterate, here are two performers. One is Steve March, whose name could be either tagged as performer or date if you tag Steve as the performer and then March as the date. And then Red Sky July, Red Sky being a performer, Red Sky July being a performer by itself, but having the word July in there is confusing for any system that we try using. And then one of the initial things that we were able to capitalize on was if you take an arbitrarily small time frame, there are very few performers that make up a large count at any given time. Obviously, these performers change, but we can use that to our advantage when it comes to tagging things. So with this, we put together our approach. So when we were given a query, pretty straightforward. If we're given a precise query, then we send it to our rule-based entity recognition system. And then for giving conversational query, we send it to a machine learning. But I'll go more into what exactly precise and conversational mean on the next slide. So precise, something like something similar to what we've had support for in the past, except perhaps a little longer of a string. And what we mean by precise is something like giants this weekend. So something that's very informationally rich. Basically, the entire query is all information that we wouldn't want to discard. It's all information that we would want to use. And then for conversational, you have something like what you might say to Alexa, like find me a Giants game in New York happening this weekend. So here the query is much longer, but that's not the only difference. A lot of it is noisy, so you can discard most of the query and still have enough information to kind of find the entities. And for this, just separating out whether or not we thought of it as a precise or conversational query, we used a naive Bayesian classifier, just extracted a couple of features such as length, kind of the amount of stop words that we would detect given some curated list that we came up with. And then on a series of generated queries, we achieved an accuracy of 96%. But we also spot checked on a couple of random queries that we would come up with in our team. So for precise queries, we decided to go with rule-based entity detection. So essentially, you just define a couple of rules and patterns, and then you look up based on, say, a bunch of catalogs that you might have for entities. The downside of this is that it's not particularly accurate. So here it says around 70%. But the main upside for this that we felt was, again, we had to take a conservative approach, as we didn't want anything, again, to use the example, a musical performer to come up when you search giants, primarily because we felt it would detract away from the user experience. So because of this conservative approach, we will return something only if we're very confident that it matches the query. And the other upside of this was that it was relatively simple to develop and debug. I know that rule-based entity detection, or rule-based named entity detection is infamously difficult. However, we decided to use just a fixed size and then using only those and not having to develop it further, as we are going to discard this system sometime in the future, sometime in the near future. So here you have something like SF Giants versus Oakland A's under $30, and that would translate into a performer conjunction and then a performer and a price. But moving on to the more interesting stuff, we used Stanford NLP and specifically the conditional random fields model to achieve our named entity recognition. For the longer queries, the conversational queries that we wouldn't want to provide pattern-based detection for, there's a word missing there, and it's supposed to be this weekend. I don't know why it's not showing on the screen. But essentially, the upside of the CRF model is that you can look at the tags from the previous tokens and then use that to inform your tags of the current tokens. So like if I see unknown for find me, then I can say with higher confidence that Giants is a performer or something along those lines. Okay, I guess it's showing on that one. So for training, we would use gazettes. So basically just lists of entities. For these features, these are primarily generic features or generic configurations and features that we found with the model. So for shape features such as the number for n in n-grams, or like to use ordinal such as first, second, third, and so on. For use word, we kind of meant it more as we could bias the entity detection based on certain features that we extract, which I'll go into a little bit more on the next slide. But in total, we used 27 features and got around 95% accuracy on generated queries. And the reason the asterisk is there is because, again, we didn't have user data for these things, meaning that we wouldn't be able to give a very accurate read on how well it would perform on user data. However, we hoped that using this combined with the rule-based would allow us to tune the NLP model much better in the future. So one big feature that we extracted that we felt helped us a lot was for performer disambiguation, going back to the giants example. So as I said, there are at least three different giants performers that we have. And we collected user click count data. So essentially, if someone searches giants and they click San Francisco Giants or New York Giants, then that turns into a single click. But we can also partition that based on location. So given that location-based click count data, we were able to basically figure out which performer they were referring to. And then the other one was alias detection. Alias detection here meaning more of alias generation. So at index time, we would figure out a bunch of sources. Here's one potential source, unnamed, but probably obvious. So essentially, for the Oakland Athletics, you have the White Elephants, or for SF Giants, you have Boys from the Bay. But the reason we didn't take a more aggressive approach to alias generation, such as like mining names off of Twitter or like trending topics or something, was because we were afraid of finding offensive names. So you wouldn't want to unearth a sports team if they have a derogatory name on our site, as that probably wouldn't reflect very well. So the end result of this is you can type something such as find concerts in San Francisco this weekend under 100, and then this is what comes up. And these are all concerts in San Francisco, and they're all starting from under $100. And this is the team. Thank you. Any questions? Yes?
How many features are in your NLP model? How many features do you have?
I believe I said 27.
27 features.
Yes. Any other questions? Yes?
You start with supervised learning first, tagging.
So the approach that we were taking with sorry, I like rushed over a little bit, but the reason we did the rule-based and the NLP kind of like on top of it was because we didn't, we wanted to support as many queries as possible, but essentially we didn't have the user data to do that. Like we couldn't say like for sure if like this should match this beyond the very obvious, right? So we wanted to kind of like bootstrap that data using the rule-based on the bottom, and then like for the more complex queries, just like offload to the NLP model. Yes?
Did you do that for English only or all languages?
Currently, it's for English only, yes. Yes?
You said that rule-based was 70% was your accuracy number for that. Was it 70%? Was it 30% of the rule? 30% of the queries of that class just didn't get picked up by rules? Or were there false positives in there too?
So we noticed for the rule-based, again, we tried to make it as much as possible to not have false positives. So that 30% is meant more as it wasn't picked up by a pattern at all. But we felt that was better than just matching it with the wrong pattern, or like kind of matching it with the wrong thing and then sending a user the wrong way. For the classifier, so we generated a couple of the queries, and even though I did say like users weren't really querying in that manner, essentially there were still a kind of weird few users who were querying in that manner, so we were able to take like those few queries and use it. So I would say in magnitude it's like on the order of thousands in total. Yes?
For all the classifications that you had with like the type of event that it is and the location, Are all of those structured attributes that you have in your data set, are there any ways that for natural language you actually use derived attribution? Like somebody types in, it's a fun concert, and fun's not really an attribute that you have, but you can pick it up and correlate that to something that looks like fun.
Currently, we don't derive those things. Those all correspond to specific entities that we have in our catalog. Yes?
When you match a rule and the things you found, is the user presented with the information seeing that there's still this big diff, and you display it with the filters knowing that it understood my query?
So I think currently we don't do that. I think we discussed it with front end, and they kind of thought the focus should be more just presenting the events directly to the user rather than showing them this kind of breakdown of it. Yeah. Currently, if we'd rather show like no events or just no matches rather than try to show anything, because that might be we're told that it would be confusing to just search for something and then have something else entirely come up. I believe there are in a few cases where it'll suggest, if we're like pretty positive that you mean something, where it'll suggest like a similar query for it, but I think the front end will display if that occurs. Yes?
Have you actually used voice as an interface for your system?
Sorry, I glossed over this a little bit. We did develop a UI component for it, but I believe it went through a couple of rounds and it hasn't actually been deployed to production yet, so I didn't want to talk too much into that. But when we were using voice, kind of using like whatever native capabilities that were there, so basically, if it's on Chrome, then you just press like you use some functionality that Chrome provides to transcribe it into text. That seemed to work pretty well with this system.
And the transcribed text is stored in Solr?
Sorry, what?
The transcribed text is stored in Solr?
No, when I say transcribed text, I meant more of like in the query itself, as a query. I feel like I may have missed what you mean.
Then the query would be saved afterwards.
Yes, the query is saved, but that's like separate of the Solr collections that we have.
And how about the performance when you run through this NLP processing for each query on the runtime?
It didn't affect our performance very much. Like, since the training was done offline and the rule base is pretty quick, we didn't notice any performance degradation from whatever we currently, I believe the response time is under 100 milliseconds is our baseline.
And how big is the data set?
Excuse me?
Not the training data set, the actual set, the actual data on which you search on.
I believe we get a couple million searches a day.
But how big is your catalog?
Medium.
In the millions. I don't think I can say a specific number.
Yeah.
Yes. So I developed a functionality for it that I don't think we're using currently. Just kind of like a slightly modified exponential rolling average to see if we can track like popularity. It looks promising, but it's not in production yet. I believe that's all the questions. So thank you.
Okay, thank you.